Hello everyone, welcome to the day 2 of the SQL LeetCode challenge that we have been solving. Day 1 was all about the beginning, the general queries, the select queries, the join. In day 2 today, we'll go and talk about the aggregation. Normally, when you go and work in a company like a data analyst, like a data scientist, typically sometimes as a developer also, you will have so much of data and then you'd like to make the meaning out of it. You have to go and do some kind of aggregation so that some business decision could be taken on the top of it. And in all those cases, aggregation comes very handy. So today, with the help of these problems, I believe when we go and solve this, you will have a more insight that how powerful the SQL is, how it could be used to go and solve these real world industrial problems. So let's quickly get started and try to solve all these problems together. My suggestion to you people is that watch till the end. Even in the case if you find the query is complicated, don't worry. Just take out your time, give it a try. Try to solve it yourself. If not, go and see the solution. And in the case, if you feel that my SQL knowledge is not that great, I would like to learn this from the scratch, put that into the comments and then I'll make a detailed workshop video or detailed course on the SQL queries so that these queries which you see on the LeetCode, you just solve it like a charm. So let's quickly get started in this video. Cool, as you can see on the screen right now, let's move to our next question on this day 2, which is around basic aggregation functions. We already talked about all the join related queries, so today we'll go and solve few the aggregation related queries. So let's go and open this. So if I go and try to read this, first of all, the problem statement, it is problem 620, not boring movies. Seems a pretty interesting problem. So if I look around, the table looks something like this. This table, let me go and open my desk scribble. This table has 4 columns: ID, movie, description, and rating. ID is of type int, movie is of type varchar, description is of type varchar, and rating is of type float. ID is the primary key. Perfect. Column with the unique values for this table. Each row contains information about the name of a movie, its genre, its rating. Rating is the 2 decimal places. Float in the range 0 to 100. Okay. Now I have ID, I have movie, I have description, I have the rating. Then I move to the next. Write a solution to report the movies with an odd numbered ID and a description that is not boring. Write a solution to report the movies with an odd number ID. So those movies which has an odd number ID, and this is and a description that is not boring. Return the result table ordered by rating in the descending order. The result format is in the following example. Okay, let's try to go and see the example also. If I go and scroll down, let's say that if this is the table, which is the cinema table, in which this is the description that I have to look around. Okay, I have the odd IDs that I have to go and see, and output should be 5, right? Interesting, which is not boring. It does not have anything boring inside it. Then I have 1. It also does not have anything which is the boring inside that. And based on that, I have done the explanation. Based on that, we have 3 movies with the odd number IDs 1, 3, and 5. The movie with ID equals 3 is boring, so we do not include it in the answer. Correct. Perfect. This 3 has a boring in it. So if I have to go and write the code for it, how do we write it? Let me go and take this down. This is a very simple query, it seems. So what I'll have to do is that I'll have to go and write select star. Now since I have to go and output all the columns, so I'll give star. Select star from cinema. Perfect. Where ID, and I go and say that ID ampersand 2 is not equals to 0, and let me put it in the next line condition where, and description does not contains boring, followed by order by, we can call it as order by rating, and it should be in the descending order. If I go and try to run this, now I have to log in first to go and run this up. So I'll just log in first. So now I will log in. Let me go and run this, the code that I have written, and it has been accepted. Let me go and click on the submit button and see if it has been successfully submitted. Perfect, all 8 out of 8 test cases has passed and I have beaten 89.7% of the people who have written the same query. Let's go back and try to solve the another problem. So let's go back to SQL 85. The next question is average selling price. Let's come in here. Question number 1251, which is the average selling price. Okay, I have this table which is called as prices, right? And this table have the column product ID, start date, end date, price, and these are the different types of it, right? So integer, date, and end. Now in this table there is no single column which is the primary key. I have a composite primary key, and which are the three columns: product ID, start date, and end date. All these three columns, they combine together to form the primary key. Each row of this table indicates the price of the product ID in the period from the start date to the end date. Okay, so in this date range, for this product ID, this will be the price. Fair enough. For each product ID, there will be no two overlapping periods. That means that there will be no two intersecting periods for the same product ID. This is also a good point, noted. Now let's go down. There is a table called as a units sold, in which I have the product ID, purchase date, and how many units. The table may contain duplicate rows. Each row of this table indicates the date, units, and product ID of the each product sold. Perfect. Now write the solution to find the average selling price for each product. Average price should be rounded to 2 decimal places. If a product does not have any sold units, its average selling price is assumed to be 0. Return the result table in any order. The result format is in the following example. So input table is prices table is 1, and then I have a unit sold table is this one. So this table will tell me the price in a period, and this will tell me the number of units. If I go and combine them, the average price of a unit, I will be able to make it through this. Okay, output is the product ID and the average price is 6.96, 16.96. Average selling price is equal to total price of the product by the number of products sold. Average selling price for one product is 100 into 5 plus 15 into 20 divided by 115 is equal to 6.96. Perfect. This is the maths that it has been happening. So I have to go and write the code, combine these two tables, and then find the average price. Cool. This is a little some good quality problem. We have to do the average. We have to get the data from the multiple tables. Fair. What I go and do? I go and call it as select p dot product underscore ID. Okay. And then I go and do this coalesce, and I go and pass. I have to round, and then I have to first of all go and do the sum, and sum of p dot price into s dot units, right? And whatever the value of the sum, I'll have to go and call it null if sum, and I will pass s dot units, right? So this is the sum divided by null if sum dot units, comma 0. If it is null, then I'm gonna do it by 0. And then what I should do is that I should go into that 2, and then I should comma as 0, right? And this, what I should do is that I'm going to call it as average underscore price, as average underscore price from prices p, and then I have to do the left join. You'll be right in the left join and call it as unit sold as, and I'm going to call it as on p dot product underscore ID is equals to s dot product underscore ID, and I was s dot purchase underscore date between p dot start underscore date and p dot end underscore date group by p dot product underscore id. So what I'm trying to do, I've done a left join between the unit solds and the prices table, and then I'm printing the product ID, and then I'm doing this sum. I'm adding this, and then I'm getting this formula. I'll try to run this and see if it works. So I have this test.unit sold does not exist. Is the name of the table correct? The name of the units sold. It should be units sold. Let me go and rerun this again. Perfect. So this is accepted. Let me go and click on the submit button and see if it is submitted successfully. Cool. So I've again beaten 92.29% of the people who have submitted these queries. Let's go back and try to solve the next problem. The next problem is the project employees, problem number 1075. Let's click on it. The project employees 1, I have a table called as a project which has something called as a project ID and another is an employee ID. So project ID, employee ID are connected. Project ID and employee ID together is the primary key of this table. Employee ID is the foreign key to the employee table. So employee ID belongs to another table called as employee table. Each row of this table indicates that the employee with the employee ID is working on the project with the project ID. Simple, right? I have a table. One is the project ID, another is the employee ID. It means that this employee ID is working in this project ID and both of them is the primary key. Perfectly fine. I have an employee table which will have the employee ID. So these two are connected, right? So these two column tables which I have right now, these two tables are kind of related, right? So this employee table has all the information about the employees. It has the column called as employee ID, name, experience years, right? Employee ID is int, name is varchar, experience years is int. Now employee ID is the primary key of this table. It's guaranteed that experience years is not null. Each row of this table contains information about one employee. Each row of this table contains information about the one employee. Very nice. Write a SQL query that reports the average experience years of all the employees for each project, rounded to 2 digits, right? So what I'm doing, I have to average experience year of all the employees for the each project rounded to 2 digits. Return the result table in any order. The query result format is in the following example. Let's try to see that. So I have this project table which is a relationship with the employee ID and the project, and then I have an employee ID and how many years this employee has, right? And then I have the project ID and project average years is 1, 2. Okay. The average experience years for the first project is, the first project is 1 plus 2 plus 3. Employee ID has experience of 3. Employee 2 has experience of 2 years. Employee 3 has experience of 1 year. So it will be 3 plus 2 plus 1 divided by what the first project divided by the 3 employees is equals to 2. And for the second project is 1 has 3 years and 2 has 4 is 4 years. So 3 plus 2 divided by 2 is equals to 2.25. So what I have to do, I have to go and add the experiences of all the employees. So these are the experience year of all the employees, and this is the number of employees, right? And this is answer to 2.50. Simple, I think very much related to how we solve the last problem. I will urge you people that you take a pause now, video, you go and pause it for now, go to this LeetCode problem, try to write your code yourself, see if it works, and then come back and see if you match with my solution, right? So I have 2 tables, definitely I'll have to again go and do the join. So I go and write here, let me go and bring it left here. So I'm going to call it as select project underscore ID, because that's what we have to print, right? What all things we have to print? with the project ID and the average years. Perfect. And then what I have to do is that I have to write round, ROUND, and then inside this we're going to call it as AVG, and then I have to go and find experience underscore years, experience underscore years, and it has to be rounded up to the two digits, and I go and call it as average underscore years from project P, and I go to the left join, and I go and call it employee E on P dot employee ID equals to E dot employee underscore ID group by project underscore ID. So what I'm trying to do here is that I've done the left join between the employee table, right? I've done the left join between the employee table and also the project table, okay, on which employee ID this thing is there, right? I'm grouping by the project ID. I'm grouping by the project. So when I go and left join this, I'll have this project ID, I'll have the employee ID, have the experience years, right? So I'm grouping by the project ID, and when I'm grouping by the project ID, I can use it in this select clause. And then I'm saying that you go and find the average of the experience years, right? Round it to the two places of the decimal and print it as the average years. So to run this and see if it works. Perfect, fine. So my solution has been accepted. Let me go and submit this. Cool. So again, my solution has been able to beat 80% of the solution that has been submitted so far on the LeetCode. Let's go back and try to solve another problem. Percentage of users attended a contest. Let's click on this and understand this, what the problem is. It's problem number 1633. Percentage of users attended a contest. Okay, sir. It is having a table called as users. Users has two table column names are user ID and username. User ID is of type int. Username has a type of varchar. User ID is the primary key. So this is my primary key, boss. Here, this is my primary key. Column with the unique values for this table. Each row of this table contains the name and the ID of the user. Fair. This is okay. Now I move further down. I have another table called as register, right? This register also, so user ID, first table is user ID and the username. So this is all specific to the user, right? So all the metadata about the user will be in this table, right? So this is this table. The second table is register table, right? In this register table, I have something called as user ID and I have something called as a contest ID. So contest ID, user ID is the primary key. Combination of column with the unique values for this table. Each row of this table contains the ID of a user in the contest they registered into. Okay. Write a solution to find the percentage of the users registered in each contest rounded to the two decimals. So out of all the users, find the percentage of the users registered in each contest rounded to two decimals. Return the result table ordered by percentage in descending order. In case of a tie, order it by the contest ID in the ascending order. The result format is in the following example. Okay. So I have this user table that I see. I have a register table that I see that which tells that which user is registered to which contest. And then I see that in the contest ID 208, the percentage of the people who have attended is 100, 209 it is 100, 210, 100% of the people have attended, like this. Good question. Now, I want you people to, just like the previous one, pause the video, go and give it a try. Try to run the SQL code for it, submit it. If you are able to execute it and run it, find the solution, great. Put your queries in the chat. If not, then come back and watch this back. So if I go and try to see the explanation of this, all the users registered in the contest 208, 209, 210, The percentage is 100%, and we sort them in an answer table by contest ID in the sending order. Okay. Alice and Alex registered in the contest 250, and percentage is 2 by 3 into 100 is 66.67. Cool. So it looks simple. It involves multiple tables, so I'll have to do the join, and then I have to run some kind of aggregation. So what I do here is, it's a very simple problem. So now let's try to start writing the query for here. So what I do is, we go and write select, and we go and call it as r.contest_id, and then I have to do the round up. So I go and set that round, and then inside this I go and set that count, and inside this I go and say that distinct, and I go and call it r.user_id, right? And then what I do is that I go and multiply this with 100 divided by, inside this I go and write a select query, select, and I go and call it as count star from users, and this comma 2 as percentage from register r, group by r.contest_id, order by percentage dsc r.contest_id asc. Let's try to run this and see if it works. If I click on the run, let's see if this query works for us. There is some error here. Why is that? I go and write it, select r.contest_id. I have this round, and inside this round I'll have to put a comma here. So to run this. Now again there is something called percentage. I think there is some typo that I have done. So it is percentage. Let's try to rerun this again. And I'm purposefully not editing out the mistake, because when we write the queries, when we solve the problem, there's always a chance that we'll do mistake. So we should just read out what the error is, and then based on that we should try to do the correction. So we have been able to solve this problem as well. Let's try to move to the next one, and we are really doing some cool progress. In the case you are not able to write the SQL queries, put that into the comments. If you need me to create a detailed video around SQL queries, I'll generate and create a free course on this YouTube channel, so that you guys have a solid understanding. And then when you come back, these kind of queries you should be able to write and solve. Let's move back and let's go to the next question. This is already done. Let me go and submit this first of all. And I see that I have been able to beat 54% of the people in this question itself. Let's move to the next one, queries quality and percentage. Okay. Let's try to see what the question is. It says that queries quality and percentage. I have a table which is called as queries, and then it has a columns name. So if I look around, I have the columns names such as query name, result, position, and the rating. The name of the table is queries. Fair enough. Then I go down. I have this table may have the duplicate rows. The table contains information collected from some queries on a database. The position column has a value from 1 to 500. The rating column has a value from 1 to 5. Query with the rating less than 3 is a poor query. Okay. The position column has a value from 1 to 500. The rating column has a value from 1 to 5. Query with rating less than 3 is a poor query. We define query quality as average of the ratio between the query rating and its position. We also define the poor query percentage as the percentage of all queries with rating less than 3. Write a solution to find each query name, the quality and the poor query percentage. Both quality and the poor query percentage should be rounded to 2 decimal places. Return the result table in any order. Okay, there is no ordering which is needed. The result format is in the following example. So let's say that I have the query table, query name is dog, result is golden retriever, position is 1, rating is 5. Then query name is another dog, result is German Shepherd, position is 2, rating is 5. Like this, I have multiple queries. Output is query name, quality is 2.5, and poor query percentage, cat 0.6, 33.3. Dog queries quality is 5 by 1, 5 by 2, 1 by 200 divided by 3 equals 2.50. Now what is this ratio? We can say that The average of the ratio between the query rating and its position. So for the dog, it is 5 divided by 1, 5 divided by 2, and 1 divided by 200 divided by 3 is 2.50. Dog queries, poor query percentage is 1 out of 3 divided by 100 is equal to 3.3%. Okay, and how do we define the poor quality percentage? The quality as this, the percentage of all the queries with a rating less than 3. Percentage of all the queries with a rating less than 3, so 1 divided by 3, right? So 1 has percentage less than 3, so 1 out of 3 queries is 33.3. Similarly for the cat, it is 2 by 5, then 3 by 3 plus 4 by 7 divided by 3 is 0.66, and cat queries poor quality performance is 1 by 3. So this is the maths that we have to do, and I think this looks simple. Let's try to write the query for the same, right? So what I can do here is, let me do this. So I will select query name, so select query underscore name, and output is query number name only, right? Query name, quality, and okay, so these two are the aggregation functions itself, right? Select query name, then I go and call it as round, and then I go and pass average, and then I go and pass as rating divided by position, and this has to be rounded by 2 as quality. Perfect. And then that should be comma here. I should again do the round, and then it should be equals to sum, and then I go and call it as case when rating is less than 3, then 1, else 0, end. Okay, and this should be multiplied by 100 divided by count rating. This is the sum that I have, count rating comma 2 as poor underscore quality underscore percentage from queries group by query underscore name. Okay, so I have this query name, so I have to group by the query name. Then I have a column name called as quality, and then I have a column name called as poor quality underscore percentage. Let's try to run this and see if it works. So it has a wrong answer. It should be poor query percentage. Is the name wrong? Okay, it should be poor query percentage. Let's try to run this again. Now it's perfectly fine. It has been accepted. If I go and click on the submit, let's try to see that how many people have beat it now. So my solution has beat it 57% of the people who have submitted the code on the LeetCode as of today. Let's go back and solve little more problems. The next one is a medium difficulty problem, which is the monthly transactions one. Let's go and see what it is. So monthly transactions one, it has a table called as a transaction, and so this table transaction has a columns called as ID, country, state, amount, and transaction date. Okay, ID is the primary key of this table, so this is my PK. Perfect. The table has information about incoming transactions. The state column is an enum of the type approved or the decline. So with the transaction, so basically this is, this is basically a transaction state. Cool. Write an SQL query to find for each month and country the number of transactions. Write a SQL query to find for each month and country, for a given country for each month, the number of transactions and the total amount, the number of approved transactions and their total amount. Here in the result table in any order, the query result format is in the following example. This table has information about the country, state, amount, transaction date, and the ID. I have to go and say that for a given country in a given month, what was the total number of transaction counts? What is the approved count, and what was the total transaction amount, and what is the approved total amount? Transaction total amount and approved total amount. Okay. So it's a good aggregation problem. Let's try to go and write the solution for this. So this is a single problem, so I don't have to do any kind of join, but I have to go and do the aggregation here itself, right? So I go and say that since I also have to go and provide month, country, blah blah, so I have to go and provide the month and the country, right? So I'll have to go and provide select, and I go and call it as date underscore format, and I go into the trans underscore date. This is how it was. Transaction date was trans date, right? Yes, it was trans date. And I have to go and get something called as year and months. So I'll go and write percentage year and month. Then I go and set the country. Then I go and set the count. Transaction count. I have to go and set the count. State as trans underscore count. And then I will have to go and approved count, right? So sum. And I go and say that if state is equals to approved, then 1, otherwise you go and do count it as 0, and this is how you go and find the sum. And as approved underscore count. After approved count, I have the transaction total amount. Right? So I can say the sum amount, and I go and call it as trans underscore total underscore amount, and then I have sum if state approved, then it should be the amount, otherwise value should be the 0, and this should be counted as approved total underscore amount from transactions group by 1, 2. Let's try to go and run this. So my solution has been accepted. Let's try to go and submit it if it works. Perfect. So my solution has been accepted and it has been able to beat 72.9% of the code that has already been written. Let's go back and solve another problem which is there on the hand, which is immediate food delivery 2. Let's see that. So this is a problem number 1174, immediate food delivery 2. This is a table called as delivery. It has a column name and it has a type. Column names are delivery ID, customer ID, order date, customer preference, delivery date. Okay. The delivery ID is the column of the unique value of this table. So basically this column that you see is the primary key. So this is all the information about the delivery. What is the delivery ID, which is the customer ID, order date, and customer preference, delivery date. The table holds information about the food delivery to customers that make orders at the some date and specify a preferred delivery date on the same order date or after it. Fair enough. Then I go down. If the customer's preferred delivery date is the same as the order date, then the order is called immediate, otherwise it is called scheduled. Okay. The first order of a customer is the order with the earliest order date that the customer made. It is guaranteed that the customer has precisely one first order. Write a solution to find the percentage of immediate orders in the first orders of all the customers, rounded to 2 decimal places. The result format is in the following example. Okay. So it is saying that out of all the orders which was placed as the first order, how many of them were the immediate orders and how many would be at scheduled order. I think this will give a good insight that as a company I should focus more on the immediate ordering, or let's say there's a demand for a even in the food delivery apps, the people are looking for a future orderings of the food items. So let's say that I have the delivery table which are delivery ID, customer ID, order date, customer preference, delivery date. Okay. And the output is the immediate percentage 50%. Explanation: the customer ID 1 has a first order with the delivery ID 1 and is scheduled. Customer 2 has delivery ID 2, which is immediate. Customer 3 has the first order ID, which is also immediate. Customer 3, its first order ID is the customer 3 has the first order ID with ID 5. Okay, the one with the earliest date, right? So this is scheduled. Okay, that is immediate. Hence, half the customer have the immediate first orders. Perfect. This looks manageable. So I have a table. Let's me write the code. But before that, you guys can pause the video here. Try to go and solve this problem yourself. When you find the SQL queries, put that into the chat and let me know that if you have been able to solve this problem. So I'll go back and try to write the code for the same. So what I'll do here is that we go and write it select. Now what are the outputs that I have to go and provide? Only one, the aggregative value, which is the immediate percentage, right? So I go and say that round. And then inside this I'll go and say that count. And then I'll go and say the case when d dot order underscore date is equals to d dot customer underscore pref underscore delivery underscore date, then 1, and then I am end. And then I'm saying that this should be divided by count star 200 comma 2 as immediate percentage from delivery d where d dot order underscore date equals to select from delivery where customer underscore ID equals to d dot customer underscore ID. So we try to go and see analyze what we are trying to do here is that I'm seeing that I'm trying to find the count of such orders, right? So when the order date is equal to customer preference delivery date, then it is 1. I'm counting that as 1 divided by the count, right, as the immediate percentage out of, so the one which is the immediate divided by total will give me the immediate percentage, where the minimum order date from the delivery by the customer ID is equals to d dot customer underscore ID. Let's try to run this and see if it works. So I have a issue here. We'll have to figure it out. What is that? So I have this round. So I have to write count, then case when d dot order underscore ID date equals to d dot customer underscore preference underscore delivery underscore date, then 1, and end, and that divided by the count star, and then it should be 100, and then it should be 2 immediate percentage from delivery D where d dot order underscore date is equals to select minimum order date from delivery where customer ID equals to d dot customer underscore ID. I think this looks fine. There's an error. I think there's some syntax error. I have missed one bracket. There should be one more bracket here. If I go and run this now, It has been accepted. Let me go and click on the submit button, and the code has been submitted. Let's go back and let's try to solve another last problem in this category of the basic aggregate functions. So I want to click on this. This is the question number 550, gameplay analysis 4. Okay, what is the question? Let's try to see that. I have a table that looks something like this. I have a player ID, I have a device ID, I have the event date, and I have the games played. Okay, this is a count. My primary key is a combination of player ID and event ID. So this is my primary key. It's a primary composite key. This table shows the activity of the players of some games. Okay. Each row is a record of a player who logged in and played a number of games, possibly 0, before logging out on some day using some device. Okay, there's so many sums, right? So it is saying, let's read it again. No, it's a little confusing. It says that each row is a record of a player who logged in and played a number of games, possibly 0, before logging out on some day using some device. Okay. Write a solution to report the fraction of players that logged in again on the day after they first logged in, rounded to 2 decimal places. In other words, you need to count the number of players that logged in for at least 2 consecutive days starting from their first login date. Then divide that number by the total number of players. The result format is in the following example. Activity table, player ID, device ID, event date, games played. Output is fraction is 0.33. Only the player with ID 1 logged in back after the first day. Logged in first second didn't logged in, third didn't logged in, third didn't log the exactly next day, right? So the answer is 1 out of 3. Cool, no? See, using the SQL queries, how much great you can go and analyze the data, right? It looks very fascinating. Before I write the code, I'll again urge you people to go and pause this video, go and read it out, try to write your own queries and see if it works, and then come back and see if your answer is right. Let me give it a try. Let's try to solve this problem. So again, I have to just provide this fraction as an output, right? So I will just go and write this. So let me go and call it as with login underscore date as select player underscore ID minimum of all the dates when the event happened. First event underscore date as first underscore login from activity group by player underscore ID. So what I'm trying to do here is I'm saying that player ID minimum event date is the first login from the activity group by the player ID. So for each of the player ID, I will know what is the first login date, right? So this will go and return me the player date, and it will also get me a column called as the first login information, right? So I'm fetching this data out from this table. This is the first login, and then I go and call it as recent underscore login as, and I write select star date underscore add, and I go and call it as first underscore login comma interval 1 day as next underscore day from login underscore date. Perfect. And then I go and call it select round, and I go to select count distinct, and I go and pass player underscore ID. And select round. This should be like this. This one from, this is cool, from activity where player underscore ID event underscore date and I'm going to call it as select player underscore ID next underscore day from recent underscore login divided by select, and let me write count. Let me go and call it as count distinct player underscore ID, and then I will consider from activity, and then I will call it as comma 2 as fraction. It has been a long query. Let me see if it works. That's the challenge of the recording live and then just recording it without editing. Let's try to run this and see if it works. Test.activity, I have done some typo. Where is that? Activity. Let's try to run this again. Perfect. This query has run. So this has been a quite bit of the query. Take your time, pause, go and look around this what I have written, try to understand that and put that your understanding in the chat. Let me meanwhile try to click on this submit button and see if this works, and I have been able to beat 90.7 people who have written these queries. So with this we have kind of completed all the queries which is around the aggregation. So with this we'll close this video. We have work around with multiple tables. We saw that how the two tables could be joined, and then we run the aggregation queries on the top of it. I hope it was helpful. In the next video we'll move next and try to solve the remaining of these queries which is still pending. I'll see you in the next video. Perfectly, sir, we have come to the end of this video. A lot of aggregations, lot of complex and bigger queries. Not actually complicated though if you understand the concepts in the code. I hope you have been able to solve all these. If not, please watch this video again. Make sure that you're solving all these problems because these are actually relevant. By solving these aggregation functions, the SQL queries around the aggregation, you would have realized that how powerful the SQL is. Data in the form of a table, then when you write these queries, you get so much of magical information out of it. So I hope you enjoyed it. Please let me in the comments if it is working, if it is helping you guys, and in the case if you feel that SQL video is necessary for you people to go and solve it, please let me know in the comments. I'll make sure that I go and create a detailed course on SQL. I'll see you guys in the day 3, the next part where we go and solve the remaining of the LeetCode problems. Thank you, and I'll see you in the next video.